You tried. It was too difficult. All right, guys. Ramirez, thank you. Quit playing with the ball. Are you okay? All right, guys, 5-1. 5-1, we're working with polynomial functions still. We need to make some observations. So let's get going. These are going to go quick. Third period was really on the ball when it came to answering these questions, so hopefully you guys are going to be right there with them. What does y equals x, what does that graph look like? Y equals x. What kind of line? Diagonal line. Okay. So, y equals x. Draw that diagonal line in the big blank spot underneath. Aw. What is the degree of this function? 1. 1. Because if I really wanted to, I could be like y equals x to the 1. Oh, now she can't even stay in here? Can't even be bothered. Number of turns, not in the slightest, Elias. I'm teaching now. How many times does that line turn? 0. Lines don't turn, that's why they're lines. Okay? Okay. End behavior. End behavior. How does end behavior always start? It goes to the same one that it is. I guess you're losing that advantage quick. Right. As x goes to negative infinity, what does y go to? Negative infinity. As I go left, I go down. As x goes to positive infinity, y goes to? Positive infinity. As I go right, I go up. The degree is the highest exponent on the polynomial. What's going on, Raymond? CrossFit workout? Okay. Okay. Y equals x squared. What's it look like? What's it look like? We just had an entire module about them. Parabola. Okay. The degree is 2. How many times does it turn?
2.
Once. It's turned once. It went turn. All right, end behavior. As x approaches negative infinity, y approaches positive infinity. As x approaches infinity, y approaches positive infinity. As I go left, I go up. As I go right, I go up. Only to you, Cameron Schnicker. At you, Cameron Schnicker. Y equals x cubed. Okay. Y equals x cubed. What's its degree? 3. How many times does it turn? Twice. What's its end behavior? As x goes to negative infinity, y goes to? Negative infinity. It goes down. As x goes to positive infinity, y goes to? Positive infinity. It goes up. No.
So, is whatever cubed function, or whatever
Mm-hmm. Yeah, that's our observation at the bottom of the page. She didn't look at me at all. She was staring at her paper. Don't worry about it. No. Destiny never smiles or finds anything funny.
She smiles.
No. Right now, she got the most dour look on her face. Just complete sourpuss. Is that your walker look? Is that what you're doing right there? She's trying to look intimidating. No, you know when you first did it, because right now your head was down, you were like. Lift it up a little bit. Your love lifting me higher than I've ever been lifted before. I really have no idea how often like stupid stuff comes out of my mouth. I will never listen to any one of these recordings because I would just be cringeworthy. What? I've never done that.
Can I guess on the next ones?
Sure.
Look, I don't have it. Oh, I do have it.
Okie dokie. Whatever.
I want you to read it before you go to soccer. You should have given me time. You act like you don't want to. I'm excited to read the letter. That was sarcasm. What?
Whoa. What's up?
Daughter.
Almost. Not the same thing. Sione, what's going on?
For the next one?
Yeah.
Oh, okay, for the first one, it's flipped, or it's going from left to right.
Okay, this one?
That one is going downwards.
Yep. Last one?
And that one starts from the left going down to the right.
Okay.
Everything just stays the same for the behaviors.
Not the end behaviors. No, I switched them all while you were not looking.
That's like a cheat.
All of them.
Oh, you did.
Is it just everything in reverse on the bottom?
Yeah, pretty much.
Okay, then I'm just gonna write that down.
Really?
Yeah.
Is that you gonna understand what that means?
Copy, paste.
I probably won't, but it's okay.
Is it?
No, it's
How do you
not.
copy and paste?
Oh, you circle it, then click it. Okay, then drag. Man, sorry.
It worked for my first one.
Windows no longer supports your operating system.
Oh, Mr. Bates.
Operating on Windows.
I even took a screenshot to prove it while I was watching the video. It does show up with the purple screen.
Nice.
Oh my god, I was like, what was that?
I made that light like very. Hey man, I missed the chart. I can't imagine her ringtone in public though. You just hear it.
Well, I imagine having that ringtone.
Yes.
What'll happen is if you were with if you were with a group of pretentious people, anyway, who don't want to admit that they have no idea what the heck that is, they're going to do something along the lines of, "Oh, what's that from? I forgot," and act like they've seen some movie where that's from or something like that. And you're gonna be like, "Oh, you think you've seen it?" And they'll be like, "No, I think I've seen that." And you'll be like, "No, you haven't." And they're like, "Yes, I have."
No, you'll be like, they'll start to help them out.
Yeah. Yeah. There you go. Yeah. All right. Give you enough time. Zip it. Sione is correct. Each of these are just flipped vertically. So the first one, it's instead of going from low to high, goes from high to low. The parabola is now upside down, and the cubic also, instead of going from low to high, goes from high to low. As x goes to is always the same on n behavior. The degrees are all the same. The number of turns are the same. Those didn't change. And then the n behaviors just swapped. The n behaviors swapped. They're opposite of what they were. Elias.
Wait, but the degree 2 didn't swap?
No, still a degree 2. It's still an x squared.
The end behavior, the second one. The first y was always negative, though. Was it not?
No, they were both positive.
Well, what you wrote was negative.
Sorry to hear that. I can literally go back to the page where I wrote them both positive.
I held my breath. Now I'm lightheaded.
Did you really?
So the first one
Kaylee, why is... What's going on here?
she's just a bean soup.
Okay. So our first big observation, what conclusions can we make? The note at the bottom of the page. I already got one of them from Destiny. What was the conclusion you made, Destiny?
The number of turns is 1 less than the degree.
The number of turns, I'm going to change your sentence just a little bit, only because she wrote it already. No, I'm going to change your sentence a little bit because it's important. The number of turns is up to. The number of turns is up to 1 less than the degree. Up to 1 less than the degree.
Oh, because like if it's a higher number,
If it right, because it
exceed the number.
if it's to the 9th power, it could turn up to 8 times. It doesn't have to turn 8 times. It could turn up to 8 times.
Can you restate that?
Yeah. Are you okay, Destiny?
I was doing that to Natalia.
Okay. The number of turns is up to degree minus 1.
And I bet you the other one got them reflected. Not inverses, that's too much.
The other two observations. Now, third period, the way they came up with it, because I write it down however they come up with it. The way they come up with it, broke it into 4 cases. I like them. I usually only deal with 2 cases, but your guys' call. Do you want the more broke down version? Okay. All right. So when it comes down to the other things that we can talk about, I want you guys to come up with them. What do you notice about the graphs? Don't worry about positive versus negative. Don't worry about that. Don't worry about the positive versus negative. It flips them. We know that. That's vertical reflections. Think about the end. Make an observation regarding the end behavior. Any observation? End behavior? None? What's opposite? When? Really? I need something more concrete than what you're giving me. Come on, guys. Don't let third period beat you. I said it's about the end behavior.
Oh, well, you said that it's everything in reverse.
I said don't worry about, just focus on only the top ones or only the bottom ones. I don't want an observation between the two of them.
Oh, okay, let me see.
Aldridge?
As x approaches infinity, it's swapped.
What?
What are you talking about?
Okay, so you have when it
Raymond, Diana?
you have when it approaches negative infinity, but that doesn't change.
Don't compare the positives and the negatives. You have 3 things up here, you have 3 things down here. Just focus on these. Don't even talk about these at all. At all. Pretend these weren't here. What observation can you make about the top ones?
Well, for y equals x, like just the straight line, all of them are the first 2 are okay. As x goes to negative infinity, x goes to infinity, and then on the bottom one, those 2 are swapped, right?
Are you talking about the bottom half ones again?
No.
Okay.
No. Okay. As y goes to...
I should only be hearing Kaya right now.
Oh, wait, no. I have something, and I lost it.
Holly? What you guys, you use too many pronouns. I need specific language here. What are they? What do you mean by that? Quit acting like you're all shut down, Destiny. Elias.
It's a wild guess, but like for as y goes to infinity.
Why x goes to infinity?
No. Like so. Well, it does.
Don't point at the bottom ones. Don't even point at the bottom 3. We got nothing, guys.
I saw some. Wait,
It's gonna be so obvious. The first
they're all the same.
the y equals x and the y equals x
Both as x equals.
3 are the same.
There we go. So try to genericize that more, Kelsey.
I literally just said
Okay.
they're all the same.
Y equals x and behavior, and the y equals x cubed and behavior.
So what do you think's the same between y equals x and y equals x cubed, Kelsey?
I don't know.
Oh, the odd.
The odd. Odd and behaviors are the same.
I was getting there. You know when I said like the numbers in the
'Kay.
very beginning, you're like, I don't know about that. And I was like, And so
All right. Odd and behaviors are the same. So positive, odd,
I was gonna say something.
and behaviors. Positive, odd. Wow. I hope that was caught on audio. Yeah, that's all I'm saying. Positive, yeah, under the conclusions. Positive, odd, and behaviors start high. Or sorry, start low and high. Okay. I'm gonna cheat. All right. Negative. Now we can switch to the bottom ones. Negative, odd. And behaviors start high and low. Oh, now you can see Elias? Jeez.
Wait, you notice in the period too? This is the smallest thing on there.
Are we your favorite class?
You're not there yet. I've always got to have at least one, right?
Not third period.
4. Then we're done. I don't know what you're talking about. Oh, man, my hand's cramping. Oh, I wrote all this down. Oh.
Mr. Bates, I want to
We should take a break.
Carefully.
In your classroom before class starts.
time is it?
But I'm writing big right now. Right.
That's it. That's it. That's all you got to fit down there.
That's a lot. That's all?
That's all.
Oh. Cool.
Right?
You should ask me what time it is.
Oh, I can fit it.
Oh, look at my wrist. What time is it, Dimitri?
I don't know.
I don't think.
All you need is love. Oh, that's right. I got my Beatles fan right there. We'll call her Beatlefany.
That should be my. Oh, that wasn't even her. That was us. Hey.
Whoa. Whoa, whoa. I'm sorry here. Isabella, Bethany is my Beatles fan. Okay? I think
It's okay, because we're the bees. It's a
Beetles can fly.
you're the bees.
No, yeah, I'm big bee. She's a little bee. It's been a thing. It has.
Okay.
Are you not? Are you done with it? I am. Okay, so actually, I'm not throwing it away.
Mr. Bates,
Mr. Bates, what time is it?
something's really irritating.
I got you. It's 2:10.
There's a little black thing at the bottom of the screen. Is that a fly?
That didn't work even a little.
What? You just wonder how I got that? Because of lies at the time, and I was like, oh, it should only be like
Sunday next. Not Sunday. Saturday.
Sunday. You guys seem very distracted today. Especially right here.
Oh! Why won't you act it? Aren't you on Windows? Where's the mouse cursor? Why won't you activate Windows?
That's so annoying, isn't it?
No. Happens once every 3 hours since I've ever had this, so for the last 3 years.
Why won't you activate Windows?
Fight the system, man.
You're on Windows.
All right, talkative children. And Michael on his phone. And Seth, who's laughing at Michael for being on his phone while he's on his phone. So, Seth, there's not much to look at there, man. Hey, guys. I just talked about how distracted we are today. And you're literally karate chopping a ripped sandwich baggie. Okay. Guys, I'm about to assign the homework without continuing the notes because of the fact that we are not focusing. You're gonna. Okay? Because if we don't want to pay attention, then that must mean we're so confident in our math skills we don't need a teacher. All right, then. Thank you, Michael. All right, guys. So this was the observation you guys made, right? If you have a positive odd, it starts low, ends high. If you have a positive even, it starts high, ends high. Negative odd starts high, ends low. Negative even starts low, ends low. All right. Now, I would challenge any of you guys, if you were to actually try to graph y equals x to the fourth, I want to talk about the fact that it doesn't necessarily turn 3 times. The literal function y equals x to the fourth will look like a fattened parabola, just a little bit too. So if I were to say, you don't have to write this down, if you have y equals x squared, it looks like that. And then I said, what's y equals x to the fourth look like? And I'd be like, it looks like that. Okay. Right? And my 2 parabolas could look like that on any given day if I'm freehanding. Now, if we were on Desmos or something along those lines, then we'd be able to see the difference. But we don't. However, an x to the fourth could also look like this. An x to the fourth could also look like this. Right? So these are all different options for the x to the fourth. Here you've got the x to the fourth turned 1, 2, 3 times, but it's a positive even. So it still started high and ended high. Here the x to the fourth turned twice, 1, 2. Actually, technically 3 times still on this one. It turned here and then turned back again here 3 times to get there. All right. So with that, The next part's a simple concept. We have 8 minutes, but we're gonna finish at least that top half of the next page. Very easy questions. Pisha Moon's gonna answer. Okay. Pisha Moon, if x times y equals 0, what can we determine about x or y? X or y equals 0. Can you actually give me a full, like, very complicated sentence about that? Like, it's a very easy concept, but I want you to extend that concept even further. Maybe they know what I'm talking about, but then you're saying and just how would you answer the question in your own words first? Okay, what can we determine about x or y? Give me a full sentence. Your answer was correct, but I want a full sentence. So take out the pronoun. Don't say it's. Just say what equals 0. Or, that's what I'm looking for. Because the only way we can multiply objects and get to 0 is if one of them is 0. So we'll get, I'm complicating up a super minor step. Kaya? Sure. Okay. But in math, when I say or, it includes the option of both of them. Mathematically, the word or includes the option of both. Okay? If x, y, z equals 0, give me the long complicated, Isabella. No, give me the long. Or longer. Longer. So frustrated. I want it longer. Okay. This is an important concept because I don't want to just hear later on like, oh, you just take the opposite or something inane like that. And we're going to talk about that right now. Yeah. Sure. Yep. But the OR takes care of all those. The OR takes care of all those. So if we have a polynomial, and then yours, I'm just going to write it out. If we have some polynomial that factors, and f of x is equal to x minus a times x minus b times x minus c times x minus d. So on the line underneath that, if f of x equals 0, then what? Give me the long sentence. If you think you got it, Sione, do you want me to call on you? Elias? That's correct. Okay, so if I'm able to factor something, any one of the things multiplying could be 0. Any one of them could. I don't know which one. Could be all of them. Could be 2 of them. Could be 1 of them. But one of them at least has to equal 0. Now let's solve for x on each of these. They could all, but we don't know. Okay, x minus a equals 0. Solve for x. X equals what? A is correct, Bethany. I want you guys to know why when we factor, each one of the parentheses is equal to 0. I don't want just a simple, oh, you do the opposite, because that said minus a, so it's plus a. That said minus b, so it's plus b. Don't give me some routine thing that you memorized. It's because each factor could be my 0. So I set each one equal to 0 and solve. Back up.